All right, the purpose of this video is to look at the concept of integration, which is section I in the set of notes on Engineering Math Review that I've posted online. And we will start with the following expression. If you recall, the derivative of the product of two functions, we have the chain rule. So you take the first function and then multiply by the derivative of the second function, then the second function, and multiply by the derivative of this first function, right? So we know this from calculus. Now we can multiply both sides of this equation by dx, and then what we are left with is d of uv, or the differential of uv, is going to be equal to u dv plus v du, right? So this just comes from taking this equation and multiplying both sides by dx. And so from here, I can rearrange this and write this as u dv equals d of uv minus v du, right? So all I've done is rearrange terms in the equation above, right? So if this is equation 1, equation 2 comes from just moving this u dv term to the left-hand side and moving this duv term to the right-hand side, and making adjustments for the sign. And if I integrate this expression, this gives me a powerful result, which is always useful. It's called the integration by parts. It's integral of u dv, and the derivative function, if I integrate that, I'm just going to get uv minus the integral of v du, right? So this is an extremely useful result. It's called integration by parts. And you can go back to calculus books and look for examples to do that. That's not what I will dwell on in my review here in this course. The next idea we will use extensively, actually, is the notion of an average. So if I have a function f of x, and the function f of x might look like this. Let's say this is x, this is f, and I might plot it, and it may look like this. Then the question is, what is the average value of this function over a range? Let's say from a to b, what's the average of this function? So in other words, if I just focus only on this region, this line perhaps might be a measure of what the average value is of that function in that region, right? And so the average, I can notate that by using the symbol f bar, would be defined as the integral from a to b of f of x dx. So I integrate that quantity, and then I divide that by b minus a. And also, if you pay attention to the units, when I divide by b minus a, I'm also going to get a quantity which has the same units as my original function f of x. So f, for instance, is speed, and x is time. When I do this, I'm getting the average speed of an object, let's say, over a time interval from a to b. All right, so the right-hand side, all the units of everything will match the units on the left-hand side. And in hydrodynamics as well as in statics, you probably have done other kinds of integration. So for instance, if I have a two-dimensional region, so x, y, and I have an area, then I have a piece of area over here, let's call this dA. So I can define what's called the moment of inertia of this area moment with respect to the y-axis. With respect to the y-axis would be, I take this area dA and I find out its distance from the y-axis, which would be this distance right here, would be the distance from the y-axis, and multiply that by dA, and then integrate this over the entire two-dimensional area. All right, so this will give me the what's called the first moment of area. And likewise, if I take the same quantity as the previous picture, but instead of multiplying by x, I multiplied by x squared, I would get what's called the second moment of this area function. And this is a quantity that'll come in handy in analyzing hydrostatics situations. And keep in mind, the units of this quantity I, y, y should be consistent with the units of this quantity on the right hand side. x would have the units of length. So x squared would be length squared, and area here would have units of length squared. So in which case the quantity on the left hand side would have the dimensions of L to the fourth, right? Over here the quantity I sub y over here would have dimensions of L cubed, right? So this is the length and that's an area. So these are important concepts on the integration aspect that I would like for you to be familiar with.